Welcome to Calculus.
We've always been good at math. How hard could calculus be?
On this episode, Stevenson will demonstrate.
We've looked at this problem before, and what we did is we integrated with respect to the x-axis. So I'm asking you now, what if we integrated with respect to the y-axis? Well, we have to think of this problem a little differently. Now remember, when we integrated this with respect to the x-axis, we had to break it up at 2 right here, because when we drew our rectangles, we ended up with different lower bound functions on our rectangles. Now you might be thinking, why do I want to do it with respect to y-axis? Well, what you're going to find is that if we do it with respect to the y-axis, we actually only have to do one integral. So first what we have to do is we have to make sense of where our rectangle is going to be. Since we're doing this with respect to the y-axis, our rectangle must be perpendicular to the y-axis itself. Now, once we consider this, what we have to look at now is we're going to be integrating from a direction of up and down instead of left to right. So what that means is we need to consider all the rectangles building in a vertical direction and not a horizontal direction. Normally what we do though is when we do our integral, we always do our f of x minus our g of x, right? This is what we normally do. But this has to change. Well, what is it going to change into? Well, what we want to do now is we still want to go from a to b, whatever it is, but now we need to make our functions in terms of y, and we need to look at the y-axis. So how do we modify this? How do we interpret what f of y is and g of y is? Well, the f of y function is going to be the function that is farthest to the right of the y-axis. Your g of y function is going to be the function that is closest to the y-axis. So this relationship is kind of similar to how we would treat our rectangles if we were doing it with respect to the x-axis. Alright, so in order to do this though, we need to actually change our functions in terms of y and not in terms of x. So what this means is you have to actually solve your functions so it is x equals. So let's start with the radical here. So actually, wait, let's look. Which function's farthest to the right, farthest away from the y-axis? It's the line. So that's going to be our first function. So let's start with that one. So all you're going to do is solve for x. In this case, just add 2. So that one's done. Now, the function that's closest to the y-axis is the radical. So what I'm going to do here is I'm just going to square both sides. Now that one's done. Now we're ready to actually set up our integral. So now we're integrating vertically, so we're going from 0 to 2. Now the function that is farthest to the right is the green one, which was the linear function. We resolved it for x, so it's in terms of y, so it's y plus 2. Minus, now the function closest to the y-axis is the square root function. And that one we solved for y, and we got y squared. Now we are set up. Now see, this is one simple integral. We can just do reverse power rule and solve this. So that's what I'm going to do now.